Welcome to Jedi Lessons Week 7A, Video 2. Our question is, the wheel of a car has a radius of 0.330 meters. So we have a wheel of a car. The radius, which is halfway through halfway through the center of a circle, is 0.330 meters. The engine of the car applies a torque of 372 Newton meters to this wheel, which does not slip against the road of the surface. Since the wheel does not slip, the road must be applying a force of static friction to the wheel that produces a counter torque. Moreover, the car has a constant velocity, so this counter torque balances the applied torque. The overall question is, what is the magnitude of the static frictional force? We have a few things here. We have the radius of the car, or of the car tire, which for our SI units, that equals 0.330 meters. We have the torque of the engine, which we're going to do TE. Torque of the engine is 372 Newton meters. We have the torque friction, which is the counter torque produced by static friction from the road, and that is also in Newton meters. We are working with frictional force, so for force we're just going to use F, and then the angle between the radius vector from the axle to the ground and the frictional force will equal theta, and that will be in degrees. Forces in newtons, that will be in degrees. First, we're going to find the equilibrium of the condition for torque. So the torque of the friction of the ground equals the torque of the engine, and the torque of the friction equals our force, so our radius and our force. So that means our force equating to the two torque expressions of torque engine equaling, since these equal each other, torque force equaling radius times, or torque of the torque friction equaling radius times force will also mean that torque of the engine equals radius times force. So force will then equal T of the engine divided by R. We have those two numbers right here. Which is 372 and 0.330. So if we plug those numbers in, that'll be 372 nm over 0.330 m. These m's cancel out. We divide 372 by 0.330. 372 divided by 0.330 equals 1127. 1127.2727 goes on and on. We're just going to round this to 0 decimal points. So our final answer will be 1,127 newtons, and that is how much force is applied through static friction. Thank you.